Hi there, and welcome back. I hope you had a great meal, and also I hope you had a great experience with the previous sessions talking about Apache Cordova to be used for cross-platform development using web technologies. The actual module is about looking closer into what kind of issues you will face when bringing HTML5 and JavaScript code to build a cross-platform app. And here with me, I have Paul.
Hi, nice to meet everyone.
Paul, if you want to introduce yourself.
Yeah. I can do that. My name is Paul Gilday. I'm a program manager on the Web Frameworks team, or more known as on the WinJS team. I've spent a couple years here at Microsoft. I've worked on the UI platform from components in Windows 7, Windows 8, 8.1, and the past 2 years I've been on the WinJS team. I've been working with the team really hard to bring the library cross-platform as well as cross-device using Apache Cordova. Awesome. So yeah. Great.
So we were talking since this morning about the ways you can bring that web code onto applications. And there's one specific thing that is happening with Windows platforms in the way you can bring that web code. The one thing is actually that there's native support on the app platform for JavaScript and HTML5.
Right, that's
so
correct.
that comes with lots of goods, as in the integration into the development tools, the way you can do debugging, DOM inspection, in Visual Studio. That gives you a level of control on that code, which is awesome.
Yes.
However, because there is an however, things are not always super nice in life, and so you will have to cope with something specific around the security model. Mm-hmm. So if you want to touch a little bit about that exactly, what is specific in the Windows app platform support for JavaScript to Windows that you don't have on other platforms when doing cross-platform with JavaScript?
Yeah, and so with great power comes great responsibility. And the interesting thing with our platform is that, especially in the context of Apache Cordova, Karupa on the previous talk talked about the different models that they use to actually implement Cordova under the hood. And so in the iOS and Android versions, you're essentially in a web view, and then you marshal calls back and forth out of that web view to the native platform. But on the Windows platform, we support HTML natively, meaning that you have local access to the APIs, and so we don't have to do that marshaling call. And so the JavaScript that you're running essentially has full access to WinRT underneath. And so especially in some of the ways of the web, a lot of those responsibilities have been taken care of you by the sandbox that you have in the browser. So you can't, essentially do bad things to an end user. And so on the Windows platform, you have a lot more control, but now you have to be a little more conscious of what scripts that you're using, what you're including, and what those scripts do.
Okay. So there's more responsibility in the developer's hands. However, there's also some control that the Visual Studio tools actually will add.
Yes.
And you're going to show us there's a specific error you might run into when you bring your JavaScript code, and you'll show us how that works. Just bringing a library from out there, dropping that into a Windows application, and boom, when you start it, you get that big message.
Yeah, and so I'll just switch over to the slides here, and if you have any familiarity with building a Windows 8 application using third-party libraries, you might actually run into this issue. And so we can actually switch over to Visual Studio to see this in action.
While you're switching, I'm wondering also, so why would we do that to developers? Like, why actually would we not just expose the same, functionalities and APIs as in a web context? So the reasons for doing that actually are beyond they're about security for the final user, right?
Yes, I guess there's two things. When we were thinking about the Cordova implementation, we wanted to have as fast performance as possible. A lot of in the debate between HTML5 versus native application programming, it's all about performance and that native feel. And so we could have taken a route where we web viewed the content, but we would still have to marshal back and forth. And so since we don't do that, we give you that direct access to that. And so we feel that was the right decision moving forward, but yes, we're going to have to use the developer. Will have to understand some of those implications that we've made.
Got it. So it's really about understanding that you're running in a different context.
Right. Exactly. Yeah.
Awesome. Show us actually the kind of things that you're not allowed to do, or that are flagged as unsafe in your code.
Sure. Yeah. So in this example here, I'm just including a common JavaScript library that most of you probably use. This is AngularJS. And so I'm just going to run this in the context of a Windows application. And so I've just included it. I think this is version 1.3.
So you just created a Windows Store app using JavaScript support.
Yep.
And that's what you get. For those who are not familiar with Windows Store app, you can see that you have a CSS folder, JavaScript folder.
Yep.
So like that's very common to any other web application. You see a not index.html, but default.html.
Sure.
But that's exactly the same thing as if that thing was running on a server as an app, right?
Right, yeah, exactly.
Web app.
Exactly.
Good.
Yeah. So hopefully if we click go here, we'll get our breakpoint and our error.
Nice.
And so this is good. Well, yeah, and it's bad, right? So we're going to break, and this is where it becomes problematic for the developer. Is that so we're breaking actually inside of AngularJS's code, and if I'm a developer using that third-party library, I might not be fluent in all of the programming models that is built into WinJS or built into AngularJS. And so that could be a really tough blocker for me.
Yep. And if you start like venturing into making changes to the framework for your own use, actually next time you get an update to the framework, you have to go through these changes again. So it's definitely not viable, I would say, as a solution. Go tinker yourself with the code to adapt it to Windows platform.
Yes, yeah, you will definitely incur a big maintenance cost for your application. And so to answer the question that you were talking about before is what type of interactions that are considered blockers in the security model essentially is around DOM manipulation and more specifically around script injection. So this is your inner HTMLs, your inserted JSON HTMLs, where the platform might not know where that code is coming from, and they might not know that there's inline script that will be immediately executed once it gets inserted into the DOM.
Got it. So is it something that in the philosophy is about being super safe because you don't know that code, so when the application goes through the Windows Store certification, there's no way to verify that piece of code that will end up in the application being injected by that piece of JavaScript code, right?
Right, that's correct, yeah. Good. And so as part of that is that we're considered in the local host, so those files are actually installed in the application package, and those go through the store and they go through certification. And so the end user will know that any JavaScript application that they download from the store is considered a safe and verified application. As soon as you allow remote code running from some remote server somewhere, you break that trust.
Great. So the code is dumped in the function here in your application here, breaks.
Yes.
What do you do?
What do you do? Okay. Well, the first thing you do is you can go actually look at the error message, and you can actually see the details of how to actually not work around, but work with the security policies that we've put in place. Could be assuming you're using your own JavaScript library, right? Right, yeah. Or even you
want to inject without even using something from the outside.
Even your own code might want to talk to your server and get some remote script that you need to auto-update very quickly that you won't be able to push through the store. And if you trust that content, then there are some things that you can do to allow that content to run. But that's in very specific cases. And so this documentation kind of walks you through some of the various mechanisms that are allowed in that context to work with the platform to enable that type of functionality.
Are they specific? So you mentioned inner HTML. Are there specific APIs you can think of like that are to be flagged as, okay, you might have an issue if you have that in your JavaScript framework?
Yes. And so actually this one's a great one where it talks about the automatic script filtering. This is actually the exact same example that we've been talking about, especially with doing append childs, inserts, any type of I'm adding more markup to my document, essentially, that may or may not have inline script. And so by default, we do try to to do some filtering and try to make some inert script, but we give you some of the tools that allow you to do that. If you are familiar with that code base and the code that you're using, to actually declare that it's safe content. And so I believe as we scroll down here, there's a couple of methods here where it's to static HTML, where you can still do inner HTML, but by calling this function, it makes all of your script tags inert, essentially, so that you're not actually running any inline script.
Okay, so you're doing a conscious decision of doing that, right?
Right.
As a developer.
Yes. Okay. And so if you're working with your own code, that might be very easy to do. But if you're working with a third-party library, then it's like you have to go through a whole bunch of someone else's project, issue a pull request, have a conversation, which might take a while because they have their own backlog that they're working through. And
then you end up working your own fork. And then when the main branch changes,
it might change.
Break your own fork. And okay, so we know the story.
Yeah. But one of the things that I'd like to mention is that I think we work directly with jQuery to help alleviate this issue.
Yeah, so actually Microsoft Open Technologies, when we're looking at the first release of Windows 8 and with the newly arrived JavaScript HTML5 support a year and a half ago, Microsoft Open Tech was in deep integration and work with various open source communities out there. And what we wanted to do is to say, okay, so what are the most used JavaScript framework? Let's go out and contribute to them to make them just work on the Windows app platform. So we did that with jQuery, and since jQuery 2.0, the contribution from Microsoft OpenTech make jQuery compatible with the security model on Windows Store apps. So that's good, works well. To be honest, it's a lot of maintenance on the jQuery side of things, and the contributions, we have to follow up on them, making sure that it's still there. Things are broken, we have to refix them. So that's obviously something that is impacted by the actual culture of the web developers, where doing this kind of thing, injecting dynamic HTML and manipulating the DOM are very powerful, and there are things that developers commonly use.
Yeah.
So fighting against that, as in trying to educate developers, changing the way of developing, will take time. And in that case, after contributing to jQuery 2.0, we're just like, okay, so we won't go out and ourselves contribute to every other JavaScript framework. How about we adapt things on our side? Let's start with a shim, very commonly used in the web development, and see how we can, appease or make it less a problem for web developers to integrate the JavaScript code. And this is where the JavaScript Compat library is coming.
Yes, exactly. And we recently released this at, was it OSCON, I believe, was one of the conferences?
Summer.
Yeah, this summer. And so in order to kind of help bring this solution to all types of JavaScript libraries, our team worked on building this Windows Store JavaScript Compat shim. And so if you go to, and it's open source, it was released by MS OpenTech, and you can see here our main GitHub. We talked about that very similar error that you'll see when building applications.
And I'm seeing some names of commonly used JavaScript frameworks, and we see Angular, Ember, Knockats. These are not just like the random ones. They're the ones that are used on actual websites today in mass,
traction,
production.
Yeah, exactly. And so, as this starts to scale out, I mean, there's Dojo, there's Backbone, you just can start listing off the JavaScript libraries. And so obviously it's not scalable for us to go talk to each one of those guys, and then we'll be getting requests to say, oh, well, no, talk to my favorite JavaScript library, please, Microsoft. And so that's exactly what this shim was made for.
Got it.
And so the nice thing about this is that you just get the shim, and then you just include it.
I like the description of the problem is like 10 paragraphs. Instructions is like 2 lines.
Yes.
Show us.
Here's the solution. So hopefully in this application here, so let's go to the default. I've already included the shim here, and so if I uncomment this line, hopefully the demo gods will be with me here. And so hopefully when I click go, my app is up and running. I don't see the error, and now I can start, building an Angular app on the Windows platform. And we think that's goodness.
Yep. So that means that load time, so that the Windows app platform, when loading the JavaScript framework, didn't see any issue, right, with the code in there. And this is because you put the JS Compat library just before.
Right.
So eventually I'm curious to see a bit about the code of that library to see what it does, because the magic that happens here, kind of like making safe things that are unsafe, is very interesting.
Right, yes, exactly. And so one of the things that we'll look at before is that we're actually using the same platform-supported APIs that we have documented here in this MSDN documentation about building secure applications.
Okay.
And so
there's nothing magic Microsoft-y in there. It's
exactly.
just like anyone could have done that library, actually. We're just like contributing that to the community for making
Yes.
their life easier, right?
Exactly.
Good.
And so we looked at kind of the common cases that web frameworks, the patterns that they used in terms of putting dynamic elements and scripts into the DOM. And so we can kind of step through some of this here, but you can kind of already start to see that we're kind of stubbing out some of these DOM manipulation APIs here. And as I scroll down just a little bit, you can see this is some helper code here that helps empty some things. But now you can start to see inserted JSON HTML. This is a fun one here where you can actually start putting in different strings of HTML in different parts of your document. And you can see that we're stubbing out these calls so that it'll actually go through our shim first before reaching the DOM. And so we actually do a cleanse of that code that's very similar to the code that is done in the platform. But for certain patterns that we've seen done in JavaScript libraries that we believe that are safe, and we've looked at them and we've validated them across other JavaScript libraries as well with this shim to allow some of that content to go in, but still maintaining the level of security and thus maintaining the same level of trust that an end user can expect when downloading that application.
Great. Okay. So that means you're not inserting a security flaw into your app doing that and using that script. Right.
Exactly.
Okay. And so, and when it comes to basically, if you have code that is not compliant and it's flagged as unsafe, you cannot not only just run the app, but you can't go through the store certification, right? So you just cannot publish. So how about now when you have the JavaScript Compat library in your code? So basically, you're still in your code using the usual APIs that are unsafe, and you have the JavaScript Compat library in front of it. Is it because you're using the JS Compat library from the Microsoft OpenText project that you're allowed it through the store? Is it something that actually flags that one as safe? And if you're using your own mechanism to do, like tags as safe the code, is that a difference? Do you have to use that JavaScript library Compat actually to go through the store? That's, I think, the question. Right. Yeah.
So there's no secret sauce or no magic. We're using the platform in the way that it was designed and intended, and so you yourself could have written this shim if you wanted to, and still pass store certification. We did it in a way that we believed would help most and address most of the pain points of developers using third-party libraries. Okay. So there's no secret sauce. This is the special JavaScript clear list that you can use for applications.
Great. So in the same order, of idea, that means that you still, as a developer, has to be careful what you put in your code, right? It's not a pass. Yeah. It's not a pass to just do whatever you want in your code and expose the user data on the application to issues.
Yes. No, that's very important. And so you as a developer should be very conscious of the code that you actually include. Have at least an understanding of what it's doing and how it's manipulating the application. Because essentially it's your job to ensure that the actions that you're partaking are trustworthy to an end user.
Now, that said, there's a topic I want to relate to the overall day today, which is about cross-platform development.
Yes.
So is that issue with the security model something that is specific only to the Windows Store platform, or can we consider that there are other platforms trying to use JavaScript to do native apps or to exploit the same kind of model that will be exposed to the same kind of issue?
Yeah, I think for Actually, we're seeing this today with Chrome apps. They have a similar concept of running HTML and JavaScript and CSS locally as an application, and they, in fact, also have a security policy. They use CSP as their security policy. And so I think for moving forward, for HTML5, CSS, and JavaScript, locally run applications that aren't in a web sandbox are going to face these issues moving forward. So this isn't a Microsoft-only thing, a Windows-only thing. Okay. It's a matter of ensuring that we're protecting end users for these locally run applications that could run remote JavaScript from a remote server.
Great. And so I have a last question that just came up during the discussion, so unscripted. So
Fantastic.
Now, still in the context of developing a cross-platform application, let's say I'm using Cordova and I target iOS, Android, Windows, and I'm using Angular. And as you demoed, just dumping Angular in my Cordova app will certainly bring that alert message and my application as is will not work on Windows.
Right.
Now I'm adding the JS Compat library. What's going to happen for iOS and Android? Will they just discard things in terms of the JavaScript library, or should I actually have some code that says, if I'm on Windows platform, use this library, if not, don't use it?
Right, and so we've gone ahead and we've done that for you. And so if you look in our...
It wasn't scripted, but you were ready for that.
I know. I was like, oh, it's perfect. It's lobbing it up and I'm just going to knock it out of the park. So we do the checks for you. And so we look to see if we're in that the Windows local context. And if we are, then we will apply that needed filtering. If we're not, then we won't do it because we know that we are not in the Microsoft local context. If we're in an iOS or an Android app, we're going to be in the web context. And so the web context will essentially safeguard the end user from that code. And so you're able to use it without any negative impacts to maintenance your application. So you don't have to have a separate index.html in your merges folder, for example, just for Windows to include this one script, and in your other applications you don't need to actually have that reference.
That's perfect. That's very much like cross-platform thinking. That's great.
Right. It's the hopefully the write once, run anywhere mentality. Yeah.
Awesome. Love it. So what does it mean for the future? I mean, we have a solution here, which is in the form of a shim, and shim are known for being temporary things and solutions. What's going on for the next version? I know we can't spoil too much about what's going on for the next app platform, but I'm wondering in which direction is it going in terms of the security model, needing, not needing such a shim. Can you share a little bit about that?
I can talk a little bit about that in the sense that we know that there's a developer pain point, and it's our job to remove those pain points from the system. As well as we're looking at other platforms and looking at their security models, and we're trying to understand what's the best mix of the level of security and the level of productivity for developers. And so in the future, we hope to address developer pain points and make sure that we have models in place that give you that right balance of security and productivity for your applications. So.
Awesome, great.
Yeah.
Well, thanks, Paul. I guess you are now getting ready for your next session at Win.js, where once again we're going to talk about cross-platform using web technologies. Thanks for this great talk about the JavaScript Compat library. I'm having a hard time saying the name of that Compat.
We love complex names at Microsoft.
Yeah, exactly. JS. What is the full name, by the way?
I have to actually look it up. I don't know it off the top of my head.
That's the worst.
Yes, the JavaScript Dynamic Content Shim for Windows Store apps.
Awesome. Great. Okay, so that was a talk about this thing. And we'll look forward to see you for the next one for Win.js. Still with Paul. Thank you.
Thank you.